All right, we have been multiplying exponents and looking at powers and what we do with those. And with multiplying, we also have dividing, which is its inverse. And what did we do when we were multiplying exponents with the same base? Well, we added them. So when we divide them, you're going to find out that we do the opposite of that. So if I can take this, I can look at this. Exponents are repeated multiplication. So we're going to rewrite this as a multiplication problem. And if you think you can do that by yourself, pause it and try it yourself and then turn it back on and check it. So x to the fifth is x times x times x times x times x. X to the second is just x times x. Well, if I'm doing multiplication and I have a like term, I can cancel those out. So if I have one on the top and one on the bottom, this would be like 6 divided by 6. Well, 6 divided by 6 is 1, and that just cancels itself out. So x divided by x is also 1, so those cancel out. Those also cancel out. I'm left with nothing in the bottom, so it's like I have a 1 there. And I still have x to the third. So my new expression is going to be x to the third. So if you notice what happened, like I told you at the beginning of the video here, this is going to be the opposite of what we were doing when we were multiplying exponents with the same base. And so we ended up subtracting the exponent and the denominator from the exponent in the numerator. And it says, will this always happen? And it will. It will always happen because when you are dividing exponents, it's like you're canceling out from a fraction. Alrighty, so when I'm dividing exponents with the same base, you are going to subtract the powers. So what I have right here, I've got 5 to the fifth power, and I'm in the first couple ones, I'm going to write out like I did at the top there so you can kind of see that this is 5 times 5 times 5 times 5. And in the denominator, I just have 5 times 5. And so these want to cancel out. So essentially, if I had done this, if I had taken 5 to the fifth power and 5 to the second power, I would have been able to divide whatever that numerator was in the denominator both by 25 and could have been like reducing that fraction. And then we would have ended up once again with a 1 on the bottom and 5 to the third. And so it means I can also think about this as 5 to the 5 minus 2, which is 5 to the third. So I'm going to show all the steps again for the second one here. This is m times m times m times m times m. Make sure I don't forget any. And down here I have m to the fourth. And remember, exponents are repeated multiplication. So once again, I can cancel those out. And I just end up with m squared. So I can think about that once again. I'm like, oh, the 6 minus the 4, m squared. Down here in this one, I've got p's and I've got n's. But you notice they're next to each other, so it's all multiplication. There's no plus signs on there or anything. It's all multiplication, and that's very important. If there's a plus sign thrown in there, I can't do this. But since they're next to each other, that implies that whatever these two numbers are, when I take them to those powers, I would then multiply them. So that means I can still do the same thing. So I can think about this as p to the fifth minus p to the second. and then I'll have n to the 4th minus n to the 1st. And there's a 1 there. We just don't write it. We just know there's just one n. So when I simplify that, I'm going to get p to the 3rd times n to the 3rd. Over here, in this next one, you're like, Mrs. Williams, there is a coefficient out there. And I'd be like, wow, excellent vocabulary usage of coefficient. But you're also going to notice that you can like take these into different parts here, and I can just work with their bases. I can do 2/8. I can reduce that to 1/4. And then I can look at these, and I'm going to go a to the 7 minus 3. And I can write this in several different ways. I can write this as 1/4 times a to the 4th. Or the more common way you will see this written, you'll take the a to the 4th, it's in the numerator, over 4. So that would be, once again, the more common way to write this. So that is dividing exponents with the same base.